Breakthroughs in Computation and Language, exploring AI's language innovations in the cs.CL field from July 28, 2025. This episode is presented by AI Frontiers, synthesizing 32 papers from the arXiv preprint server uploaded on that date. Imagine this. You're scrolling through your favorite news app and suddenly an AI-powered assistant pops up, not just summarizing the article in perfect French, but also explaining the medical jargon in a way that feels tailored to your cultural background, while double-checking for biases and hallucinations. Sounds like science fiction? Well, papers from July 28th, 2025 on the arXiv preprint server are unveiling breakthroughs that could make this a reality, bridging language divides in healthcare and ethics. Welcome to AI Frontiers, where the latest in artificial intelligence research is unpacked, focusing on computation and language, often abbreviated as cs.CL, and computational linguistics. This episode synthesizes 32 papers from the arXiv preprint server, all uploaded on July 28, 2025, enhancing large language models for tasks such as bias detection. The purpose is to explore how AI processes, generates, and interacts with human language for real-world impact, from low-resource languages to ethical decision-making. By the end of the episode, the revolutionary role of AI in everyday life becomes clear through accessible and fair tools. Computation and language can be thought of as the invisible translator in a bustling global marketplace, where AI acts as the multilingual merchant, handling words, meanings, and contexts to ensure messages are conveyed accurately. This field intersects computer science, linguistics, and cognitive psychology, developing algorithms that enable machines to comprehend text, generate responses, and reason like humans. It powers essential tools such as chatbots for booking flights, translation apps that bridge language barriers, and sentiment analyzers for gauging public opinion on social media. In the broader AI landscape, it is crucial because language serves as the gateway to human intelligence. Without mastering it, true collaboration with AI remains elusive. Challenges include data scarcity in underrepresented languages, biases that skew outputs, and the black box nature of models that hinder trust. Solutions are advanced through large language models like GPT or Llama, trained on vast text data to mimic human-like understanding. This field is key to making AI more accessible, ethical, and efficient, supporting applications from medical diagnostics in French to speech recognition in Shona. A key theme emerging from these papers is enhancing large language models for specialized tasks, such as web automation or clinical extraction. For instance, the work by Xiu, Zhu, and team introduces a web history compressor that distills verbose web states into concise summaries, improving action prediction. This can be likened to packing a suitcase efficiently for a long trip, ensuring the model carries only essential information. Such compression techniques are vital for creating efficient AI agents that avoid overload while maintaining performance. Another prominent theme addresses low-resource languages and domains, where data is scarce, alongside efforts in bias mitigation, which are crucial for trust in AI. For example, Leslie Wellington-Sirora's work on Shona speech recognition uses data augmentation to build robust models, effectively turning a trickle of data into a flowing river through clever engineering. This benefits millions of speakers in Africa. Additionally, Hadi Mohammadi's probe examines how models handle cross-cultural morals, revealing gaps that could perpetuate stereotypes, akin to shining a flashlight into the model's mind to uncover hidden prejudices. Bias mitigation techniques are employed to align models with diverse human values, ensuring fair and equitable outputs. Further themes include innovations in evaluation and benchmarking, as well as personalization and diversity in outputs to ensure AI is not one-size-fits-all. Satyananda Kashyap's StructText framework generates high-fidelity synthetic datasets for text extraction, like crafting a precise map to test a navigator's skills, exposing weaknesses in coherence and factuality. Meanwhile, Max Pieperkorn's conformative decoding restores diversity lost in fine-tuning. Similar to adding spices to a bland recipe for more varied and user-specific responses. Benchmarking involves multidimensional assessments that evaluate model performance across aspects like coherence and factuality, providing clear insights for improvement. Key findings from these papers reveal exciting advancements, each like a plot twist in an AI narrative. The web automation breakthrough by Zhu et al. Features a compressor that boosts accuracy by 1.2 to 5.4 percentage points, transforming clunky web agents into nimble navigators while slashing computational costs by 90%. This could revolutionize e-commerce or accessibility for the visually impaired. In Shona speech recognition, Sorora et al. Achieve a 29% word error rate using hybrid networks and augmentation, giving a voice to underserved regions in Africa and enabling better education and communication tools. Mohammadi et al. Find that large language models compress cultural moral differences, misaligning with human surveys and risking stereotypes, like a map that merges continents into one. Kashyap et al.'s StructText shows models excel on facts but falter on narratives. With multidimensional evaluations uncovering flaws in numerical fidelity, guiding improved training for enterprise tasks like financial reports. Finally, Jungwon Park's soft injection method outperforms in-context learning by 10 to 14 points while reducing costs, akin to upgrading to an efficient electric car for tailored AI responses in applications. One pivotal study stands out, automating thematic review of prevention of future deaths reports, replicating the ONS child suicide study using large language models by Sam Ocean et al. From 2025. This work blends technology with social impact, motivated by the limitations of manual reviews in child suicide studies, transforming grief into actionable insights. The objective is to use large language models to replicate and expand the 2025 Office for National Statistics study, scaling the analysis of 4,249 reports from 2013 to 2023 efficiently. It addresses preventable deaths by identifying patterns faster, such as mental health lapses or safety oversights, ensuring recommendations reach authorities and potentially saving lives. In methodology, the PFD toolkit is developed as a text-to-table pipeline using open-source large language models like Llama or Gemma. It ingests 4,249 reports, employing zero-shot prompting to screen for suicides in individuals 18 or younger, classifying without prior examples. Eligible reports are then coded into recipient categories and 23 concerned subthemes, mirroring the Office for National Statistics framework. Through extraction and classification tasks, validation involves 3 clinicians blindly reviewing a sample of 144 reports, measuring agreement with Cohen's kappa, where scores of 0.6 to 0.8 indicate substantial agreement. The pipeline handles noisy data, such as varying formats and abbreviations, by fine-tuning on a small annotated subset, and runs in about 8 minutes on a standard script. Strengths include scalability and reproducibility. Limitations note that large language models can hallucinate on ambiguous text, requiring human oversight, and open-source models may not match proprietary ones in edge cases. The findings are remarkable. The toolkit identifies 72 child suicide reports, nearly double the Office for National Statistics' 37, suggesting manual methods miss critical cases. Validation yields a Cohen's kappa of 0.82 and 91% raw agreement between the large language model and clinicians, indicating almost perfect reliability. This replicates and expands the study. revealing themes like inadequate mental health support or online risks with around 95% precision in theme extraction, enabling proactive policy changes. The model handles subtleties such as emotional language and archaic legal jargon effectively, though regional dialects pose occasional challenges. The significance extends to public health, positioning AI as a vigilant guardian for monitoring societal risks and averting future deaths through faster insights. It exemplifies ethical hybrid systems, blending machine efficiency with human empathy, inspiring tools for areas like medical error analysis while addressing challenges like data privacy and hallucinations. Looking ahead, these papers serve as seeds that could grow into a lush forest of AI possibilities, where language models evolve into adaptive, fair companions attuned to cultures, domains, and users. Future directions may include hybrid systems integrating neural networks with symbolic logic, such as ontology-enhanced knowledge graphs, for more explainable and decisive reasoning. Personalization could advance through techniques like latent inter-user modeling, reducing biases in global applications. For low-resource languages, federated learning is anticipated to protect privacy while pooling data across regions. Multimodal integrations, blending text, images, and speech, might create versatile tools for fields like aquaculture or hate speech detection. Challenges such as hallucinations and environmental costs could be addressed via efficient compression methods, inspired by geometric mean optimization for stable, green training. Overall, a hopeful horizon emerges: AI that is smart, fair, efficient, and diverse, transforming healthcare, ethics, and communication. This episode has journeyed through the frontiers of computation and language, starting with surprising AI scenarios, introducing the context, overviewing the field as a global marketplace, unpacking themes with metaphors like rivers and suitcases, sharing key findings as mini-stories from works by Zhu et al., Sarora et al., Mohammadi et al., Kashyap et al., and Park et al., delving into the Standout paper by Ocean et al. For its social impact, and peering into future directions. These July 28, 2025, papers from the arXiv preprint server demonstrate AI's evolution in understanding humans, from Shona speech to cultural morals and suicide prevention. Language technology fosters connections beyond code. Listeners are encouraged to explore these papers on the arXiv preprint server, share thoughts with #AIFrontiers, and reflect on how these innovations might change daily life. This synthesis was created using AI tools, including GPT Grok with model Grok 40709 for content generation, TTS synthesis using OpenAI for audio, and image generation using Google for visuals. The synthesized content underwent review by a human expert. Possible oversights may exist, and all references are provided. Join the AI Frontiers community by subscribing for more insights into AI research. The channel, titled AI Frontiers, delivers updates on breakthroughs. Stay informed on the latest developments. Hit subscribe now. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.